Welcome to section 20.4. This is the 206th session of the CISSP exam prep series. In this session, we'll explore systems that try to reason the way people do. We'll answer several questions. What is an expert system, and how does it decide? How does machine learning build knowledge from data? What are neural networks, and how do they learn? Where do these systems help in security? And how do you develop and run AI safely? Why does this matter beyond the exam? Because knowledge-based systems increasingly make or shape security decisions, and you need to judge whether to trust them. Picture a fraud team drowning in millions of daily transactions no human could review by hand. A well-built model can flag the suspicious few in seconds, but only if it was trained on sound data and secured against tampering. Understanding how these systems reason and where they can be poisoned is fast becoming core security knowledge rather than a specialty. What is an expert system, and how does it decide? An expert system tries to capture the accumulated wisdom of human experts and apply it consistently to future decisions, often outperforming people on routine calls. It has two core parts. The knowledge base holds the expert knowledge as a long series of if-then rules, like the guidance a seasoned advisor might follow. The inference engine reads those rules and reasons through them, using logic and fuzzy techniques to reach a conclusion for the situation a user describes. Its great strength is that it decides without emotion clouding the judgment, which is why lenders use such systems for credit choices rather than leaning on a loan officer's gut feeling about a likable applicant. Remember, though, that it is only as good as its rules and its reasoning. Think of it as a rule book paired with a referee who applies it the same way every time. How does machine learning build knowledge from data? Machine learning develops knowledge directly from datasets without a human spelling out every rule, letting the computer analyze data and refine its own models of activity. It falls into two broad categories. Supervised learning trains on labeled data, where the analyst supplies both the examples and the correct answers, so a model of malicious logins learns from login records already marked as good or bad. Unsupervised learning trains on unlabeled data, where no answers are given and the algorithm groups similar items on its own, leaving an analyst to inspect the clusters and judge which might be malicious. Think of supervised learning as studying with an answer key, and unsupervised learning as sorting a pile of unlabeled photos into whatever natural groups emerge. What are neural networks, and how do they learn? A neural network chains together many computational units to loosely imitate how the human mind reasons. Where an expert system stores explicit rules, a neural network sets up long chains of small decisions that feed into each other and sum to a final output. Neural networks are a subset of machine learning, also known as deep learning, and they power tasks like voice and face recognition. They work in many layers of summation, each carrying weights that reflect how important a calculation is to the overall decision. Those weights are tuned during a training period, feeding the network inputs whose correct answers are known and working backward to set the weights, a process built on what is called the delta rule. Through it, the network learns from experience, though no network yet approaches the true reasoning power of the human mind. Think of it as a vast chain of tiny dials, each nudged during training until the whole chain produces the right answer. Where do these systems help in security? Knowledge-based techniques have real value in security precisely because they make rapid, consistent decisions. One of the hardest problems in the field is that human administrators simply cannot pore over the enormous volumes of log and audit data thoroughly enough to catch every anomaly. A system that never tires and applies the same criteria every time is a natural fit for that grind. Think of it as a tireless analyst reviewing every line of every log at machine speed, flagging the oddities a human would inevitably miss. How do you develop and run AI safely? As AI and machine learning become woven into software, secure AI guidelines from national cybersecurity authorities call for security across the entire AI lifecycle, built on a secure by design and secure by default mindset. It has 4 stages. Secure design treats security as a core requirement, with threat modeling tuned to machine learning risks like adversarial attacks and data poisoning. Secure development protects the AI supply chain, scrutinizing pre-trained models, third-party training data, and open-source components, and guarding the training pipeline and data integrity. Secure deployment ships with hardened, secure defaults, protecting the endpoints that serve models from theft and inversion attacks, and applying least privilege to interface access. And secure operation and maintenance monitors continuously for model drift, where accuracy degrades over time, and for live adversarial behavior, with incident response ready for AI-specific compromises. Think of it as the same disciplined lifecycle you apply to any critical software, extended to cover the unique ways an AI model can be corrupted. So let's bring it together. Expert systems pair a knowledge base of if-then rules with an inference engine that reasons without emotion. Machine learning builds models from data, supervised with labeled answers or unsupervised without them. And neural networks chain-weighted layers that learn through training. These systems shine in security by consistently sifting the log data no human could fully review. And securing AI means applying disciplined design, development, deployment, and operation across the whole life cycle. Master these, and you can both use and safeguard the reasoning systems reshaping our field. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.